There are two methods to add. Actually, there are three methods. So I'll tell you all the three. One, the first method is parallelogram method. Okay, parallelogram method. Second, triangle method. Third, mathematical, analytical way we do it. And fourth, uh, uh, we use components. So each each of these methods can be give the same answer. But these two methods are based on geometry, scale diagrams. And of course, you can apply the analytical to this. From maths, you apply and you get these two here. But what is geometry? Geometry is common sense. What is common sense? That you visualize the problem and say, okay, I go from here to here, I go from here to here, then I go from here to here. You can think in terms of displacement also. Force is a vector, displacement is also a vector. So the same rules apply. So I go from here to here, I go from here to here. So the resultant way I go from here to here. Common sense. Okay. Like I'm going from, so what do we say? The resultant vector is 8 along with this direction. So this is the arrow. That means you have to consider the direction plus 8. You can't do r is equal to 8 plus 8. You have to consider direction. That's why the arrow. Now, uh, or resultant is force 1 plus force 2. Now, supposing there's some sense to this. This is triangle law. And triangle law is the most obvious. You go from here to here, then you go from here to here. And you've logically tells you you have to ultimately gone from here to here. Okay. Now the parallelogram is kind of different. Parallelogram is like you put the tails together. Here, what are you doing? You're putting the tail, then the head, then the tail of the next one, and then the head of and you are effectively going from this tail to this tail. Here, you put both the tails together. Now, if you put both the tails together, then you have to do something different. You have to construct a parallelogram, and then you say this the diagonal is the resultant. Now, this diagonal, not this diagonal. There's a difference. Now, I'll tell you what the difference is. Here, if I call this going from here to here and then going from here to here, you have to put this here and you realize that this is the triangle only. Like you're going from here to here, then here to here. This is actually equal to this. And so we do this. But what about this? Supposing this diagonal, what does this represent? This is slightly different. It's like it's like you are going from here to here and then from here to here, and this is the resultant. In that case, it will be 8 vector plus this diagonal is equal to 8. Now, this is different from what I was saying. This diagonal represents this. It represents the difference of these two. It represents the difference of these two, not the sum of these two. So you don't think consider this diagonal. You consider this diagonal. Understood?